Welcome to our geography lessons. Today, we're diving into the exciting world of maps and directions. Understanding how to read maps and use directions is not just about getting from point A to point B, it's a fundamental skill that helps us navigate our world. From the bustling streets of a city to the vast expanses of the countryside, maps guide us in ways we often take for granted. Whether you're embarking on a family road trip or exploring a new neighborhood, this episode will equip you with essential geography skills. So, let's get started. First up, let's talk about the 4 cardinal directions. If you've ever looked at a compass, you might have noticed 4 main points: north, south, east, and west. These cardinal directions form the basis of navigation. The word cardinal comes from the Latin word cardo, meaning hinge. This is quite fitting because all other directions hinge upon these 4 primary points. Did you know that the sun rises in the east and sets in the west? This natural phenomenon is something sailors, hikers, pilots, and GPS systems rely on daily. Additionally, we have intermediate directions such as northeast and southeast that help us locate places more precisely. Next time you refer to a compass rose, look for those 4 points marked clearly, often with N representing north or even a decorative fleur-de-lis. Now that we've covered directions, let's understand scales, a key element in any map. A map scale demonstrates how distances on the map relate to real distances on the ground. Without a scale, maps would be almost meaningless. For instance, a scale might appear as 1 to 50,000, meaning 1 centimeter on the map equals 50,000 centimeters in reality, or 500 meters. You might see city maps using a different scale, such as 1 to 10,000, which provides a lot of detail, whereas world maps have a larger scale. Essentially, a scale helps shrink the real world down to fit on paper or a screen, allowing us to conceptualize distances that would otherwise be challenging to visualize. Now, speaking of spatial concepts, let's explore lines of latitude. Lines of latitude slice the Earth horizontally, much like the way you would slice an orange. They're called parallels since they run parallel to one another and never touch. The most notable line, the equator, is marked at 0 degrees latitude. Moving towards the poles, the North Pole is at 90 degrees north, and the South Pole is at 90 degrees south. Each degree of latitude corresponds to approximately 111 kilometers or 69 miles. Latitude is crucial when considering climate. Areas near the equator are often hot, while regions near the poles are much colder. Now, how about we shift our focus to lines of longitude? Unlike latitude lines, these meridians run vertically and are not parallel. They all converge at the north and south poles. Lines of longitude measure how far east or west a place is from a reference line called the prime meridian, situated at 0 degrees longitude and passing through Greenwich, England. This important line was established by an international agreement in 1884. An interesting fact is that every 15 degrees of longitude represents a 1-hour difference in time zones. Now, how do we map elevation and terrain on maps? This brings us to contour lines, which you can observe on topographic maps. Contour lines are those curvy brown lines you often see. They connect points of equal elevation above sea level. Walking along a contour line keeps you at the same height. When contour lines are close together, it indicates steep terrain, like cliffs. Conversely, when they are spaced far apart, it shows gently rolling land. Concentric circles reveal hilltops or mountain peaks. This method of visualizing elevation was developed by British mathematician Charles Hutton in 1774, enabling map readers to perceive 3-dimensional landscapes on flat paper. As we explore maps further, you might wonder about the tools we use for navigation. A magnetic compass is essential for finding our way. A compass needle is a tiny magnet that aligns with the Earth's magnetic field. The end marked north points toward the Earth's magnetic North Pole. However, it's important to note that the magnetic North Pole is not the same as the true geographic North Pole. The geographic North Pole is a fixed point, while the magnetic North Pole constantly shifts, currently moving approximately 55 kilometers per year toward Siberia. The difference between the two poles is known as declination or variation, and it's crucial for navigation, especially with a compass. Now, let's turn our attention to a vital aspect of maps, the legend or key. Picture trying to read a map without an explanation for symbols, a complete mystery. The legend serves as a decoder, illustrating what each symbol represents. For instance, a blue line typically symbolizes a river, while a star may indicate a capital city. A green patch usually represents a forest, and parallel black lines might signify railroad tracks. Without a standardized legend, each mapmaker would create their own symbols, leading to chaos and confusion. The legend allows us to interpret different maps consistently and easily. Understanding modern navigation wouldn't be complete without discussing GPS technology. GPS, short for Global Positioning System, consists of approximately 31 satellites orbiting the Earth about 20,000 kilometers up. Each satellite broadcasts signals regarding its position and the exact time. Your GPS receiver uses these signals to determine its location. When your receiver can detect 3 satellites, it can calculate your two-dimensional position in latitude and longitude. But with signals from 4 satellites, it also gets your altitude, providing a 3-dimensional understanding of your location. Although your GPS can usually access between 6 to 12 satellites at once, it requires a minimum of 4 satellites for precise positioning. This technology, initially developed by the U.S. military, became available for civilian use in 2000, revolutionizing how we navigate our world. However, have you ever considered the limitations of maps? The commonly used Mercator map projection provides a perfect example. Created in 1569 for navigation, this projection distorts land masses significantly as one moves further from the equator. For example, Greenland appears larger than Africa in this projection, when in reality, Africa is 14 times bigger. Furthermore, Alaska seems to be about the same size as Brazil, although Brazil is actually 5 times larger. This distortion arises due to the stretching of polar regions to convert our spherical Earth into a flat rectangle. Despite its usefulness for navigation, the Mercator projection has led to misunderstandings regarding the actual sizes of countries around the world. Lastly, let's explore the International Dateline, an imaginary line that helps regulate time zones. It primarily follows the 180th meridian in the Pacific Ocean. Crossing it from west to east means you subtract a day, while moving from east to west, you add a day. Without the International Dateline, coordinating what tomorrow means would be challenging. Interestingly, this line isn't straight, it zigzags to avoid dividing countries, ensuring neighboring places like Fiji and Kiribati experience the same calendar day. Armed with this knowledge, you now have the tools to read maps, understand directions, and navigate your world like a pro. Let's take a moment to recap what we've learned today. We explored cardinal and intermediate directions, understanding their significance in navigation and how they relate to the sun's path. We examined the importance of map scales for measuring distances accurately, and we discussed lines of latitude and longitude, which are critical for determining location. Contour lines allow us to visualize elevation and terrain on maps, while magnetic compasses help us navigate by aligning with Earth's magnetic field. The legend on a map plays an essential role in interpreting symbols, and GPS technology has transformed how we find our way, all while understanding the implications of different map projections like the Mercator. Finally, we covered the International Dateline, which helps us coordinate time across the globe. All these tools equip you with the skills to confidently navigate our world. Thank you for joining us on this exploration of maps and directions. We hope you've gained a deeper appreciation for geography and the tools that help us navigate our environment. Remember, whether planning your next adventure or simply trying to find your way, these skills are invaluable. Until next time, keep exploring and discovering the world around you.